we have been given a hash function and a number of key values, and we are asked to find the location of a particular key value 79. The main thing that we have to answer before moving on to solving this question is, what is the value or what is the size of my hash table? See, in this question we have been given the hash function. This is my hash function, right? So my hash function is f of key is key mod 13, and what are my key values? These are my key values: 55, 58, 68, 91, 27, 145. These are my key values, and we are also asked to find the location of 79, which is another key value. The thing is, what is the size of my hash table? One thing that we know from hashing techniques or from hash functions is that this function that has been defined here, this function is nothing but the division method. This hash function is the division method, and in the division method we saw that f of key is equal to key mod h, where h is the size of the hash table. This is what is generally assumed, right? In the division method, if we use the division method as our hash function, then this h will generally be a prime number or a number without small divisors. Why? Because it will minimize the number of collisions. Also, h should be the size of the hash table. More often than not, it is the size of the hash table. So it is safe to assume that the hash table that we will be dealing with in this problem is of size 13. And one more thing that we know from the division method function is that if the function is in this form, f of key is equal to key mod h, this denotes that my indexing starts from 0. Had my hash function been something like this, f of key equal to key mod h plus 1, then my indexing, then this would have denoted that indexing starts from 1. But the function given to us is this, f of key equal to key mod 13. That means the indexing is from 0. So the hash table that we have will consist of 13 slots ranging from 0 to 12. So let's number the slots here: 0, 1, 2, 3. This is my hash table, right? 4, 5, 6, 7, 8, 9, 10, 11 and 12. So the indices range from 0 to 12, and the size of this hash table is 13. Now what we'll do is we will find the location of each of these key values in the hash table, and after filling the hash table with these key values, the ones which are given 55, 58, 68, 91, 27 and 145, we will check what will be the location of 79. And one more thing that we need to keep in mind is, if collision occurs, then we will be resolving it using linear probing. So let's start. What about 55? 55, so f of 55 will be 55 mod 13, and 55 mod 13 will come to be how much? It will come to be 3. So 55 will be placed in location 3. I hope this is making sense. I'll do it for each of the key values, of course. So what about f of 58? If I do 58 mod 13, what I get is 13 4 times, 52, I get 6. So 58 will be mapped to location 6 of the hash table. What about 68? What about 68? So I'll do 68 mod 13. So what is 68 mod 13? So 68 mod 13 will give me 13 goes into 68 5 times and leaves a remainder of 3. Now this is interesting. See, 68 is mapped to location 3, but I find that location 3 is already occupied by 55. That means there is a collision. So what is collision? Collision is allotment of more than one key value in the same location of the hash table. So this is my location of the hash table, and in this location I have 2 key values being mapped. As a result, a collision has taken place. Now it has been given in the question that to resolve collision we will have to use linear probing, and linear probing assumes this hash table to be circular in nature, and it will look into the next location from the point of collision. So what is the point of collision? The point of collision is index 3. So the next index is 4. That means we'll have to see whether index 4 is empty or not, and we find that index 4 is empty. As a result, 68 will be mapped to index 4. Next we have 91. So f of 91. F of 91 will be 91 mod 13. Now 13 goes into 91 7 times and leaves a remainder of 0. As a result, 91 will be mapped to index 0. Next we have 27. Let's see where 27 lands up. 27 mod 13 will give us a remainder of 1. Now this slot 1 is empty. As a result, 27 can go and sit there. Next we have f of 145. Now 145 mod 13 will give us how much? 13 goes into 145 11 times and leaves a remainder of 2. Now let's check slot 2. Yes, slot 2 is empty, so 145 can go and sit there. Next we have to check for 79. Next we have to check for 79. So f of 79 will give me 79 mod 13, which comes to be 1. Now this is interesting. See, 79 mod 13 has given me 1, but location 1 is occupied. So using linear probing we'll move to location 2. Again, location 2 is occupied. Use linear probing, move to location 3. Occupied. Use linear probing, move to location 4. Occupied. Use linear probing, move to location 5. You find an unoccupied cell, so you insert 79 here. As a result, 79 is at index 5, and we were asked that what is the location of 79. So we have found it to be index 5. So the correct option is D, that is 5. If you have any doubts, please leave it in the comment section below. I hope this helps. Thank you.